Sixth grade lesson 10.5 is area of trapezoids. And I know in the previous lesson I said, well, we don't have a formula for trapezoids yet, but in this lesson, we're going to take what we learned as we explore the trapezoids, build our formula for finding area of trapezoids so that we can use that from now on. And we can add that to our area toolbox. We will now know area of parallelograms, including rectangles and squares, area of triangles, and now we will have a tool in our toolbox for finding the area of trapezoids. So let's build that formula so we know what it is and why it's that way, and then hopefully it sticks in our memory. Okay, so a quick look back at what we did in the previous lesson is we had our trapezoid, and if we wanted to find the area, we thought, let's just make a match of it, flip it over, and that gave us a parallelogram. And with that parallelogram, we took the base, which was these two added together. So that's the first step we're looking at. We have this base 1 and this flipped version over here, the base 2, added together give us the whole base of the parallelogram. So we say we're going to add together, the first thing we did is we added together base 1 and base 2 to get a whole base for the whole parallelogram, right? So let's go ahead and write that as base 1 plus base 2. So we did that. And then we took the sum of that, the sum of this put together, and multiplied it by the height, because area of a parallelogram is base times height. So we multiplied the added version of that times height. Then we took the whole answer of the whole parallelogram, the whole area, and we cut that in half, or divided by 2, also known as multiplied by 1/2. Either one. Multiplied by 1/2 is the same as divide by 2. So we multiplied that whole thing times 1/2, or divided by 2. Same thing. And that gave us the area of the trapezoid. The formula to find area of a trapezoid is area equals 1/2 times height times the sum of base 1 plus base 2. A equals 1/2 h times b1 plus b2. That's the formula. So now that we have that, now it looks pretty scary if you were to first look at it and not know what all of those terms mean. Now it's not so bad. You've been kind of already doing that. You added those together, you multiplied by the height, you cut it in half. That's what you were doing in the previous lesson. We're still doing the same thing, but we're going to follow the formula. Now I'm going to tell you that if for some reason later on next year or whatever you forget the formula, it probably will come back to you fast. This is a longer one than this one. It's not as easy to stick in your memory. It probably will come back to you very quickly, but if it doesn't, you can remind yourself by flipping it over. If you draw the picture and flip it over, you'll remember that there's the parallelogram, and you'll be able to build that formula again. I add those together, multiply by the height, cut it in half. And so you'll still be able to do it if you don't necessarily remember the formula. Or you can just say, well, there's a triangle, there's a triangle, there's a triangle, there's a rectangle, and put it all together. There's other ways to do it, but if you can remember the formula, that's the easiest way. Let's look at that formula in action. Okay, so the steps to do this, much like our previous lessons, are write the formula down. And I do that not just to kind of keep our thoughts organized, but I also do that to every single problem to help brainwash our brains into memorizing those formulas. They're nice shortcuts to help us remember how to do these, or nice shortcuts to help us do these in the quickest way possible. So if we can get those memorized and get stuck in our brain nice and deep, it makes it easier for us later. So write the formula every time, then fill in the known dimensions that they provided to us, and then you will use order of operations to solve the problem. Sometimes you may be left with an inverse operation to isolate your variable, and so if that comes up, then handle that as well to solve it all. So Mr. Desmond has a table in his office with tops shaped like trapezoids. That's cool, right? because if you turn all those tables together, they would make, if you had a bunch of them, you'd have like a nice collaborative group there. The diagram shows the dimensions of each tabletop. What's the area of each tabletop? So here's our dimensions, base 2, base 1. If I called that base 1 and that one base 2, it's not a problem. You're still going to be okay. And there's my height. Find the area of the trapezoid. Step 1, write the formula. A equals 1/2 base 1 plus base 2 times height. We had written it as A equals 1/2 H times B1 plus B2. You'll see it either way. It's the same. You're multiplying 1/2 times the height times this answer. 1/2 times the height times this answer. So choose which way you want to write it that way every single time. Okay, so then we fill in our dimensions, our known dimensions. So we have, let's start with the base 1 and base 2. Base 1, 0.9. Base 2, 1.6. And then the height of 0.6. Okay, and now order of operations says I need to solve what's in my parentheses first. So I'm going to do this addition. 0.9 plus 1.6 will be 2.5. Now, because there's only multiplication as all my operations that need to be done, I could do 1/2 times 2.5 or 1/2 times 0.6. I could move the order around. I personally normally would look for even numbers to cut in half because even numbers are easy for me to cut in half. They didn't do that, however, so I'm going to keep going their way. We're going to do the 2.5 times the 0.6, and I get 1.5 on that. Then I'm going to do 1/2 times 1.5 or 1.5. And actually remember, 1/2 times something is the same as divided by 2. So I'm going to do 1.5 divided by 2. And that is going to give me 7 for 14 with 5. 0.75. So the area is 0.75 meters squared for that. Okay, let's have a look at another one. Again, the steps to solve the area of a trapezoid. Write the formula down, fill in the known dimensions, and then solve using order of operations and, if necessary, inverse operations if you need to isolate a variable. So step 1 has been done for us. Here is our formula. A equals 1/2 times the sum of base 1 plus base 2, also times the height. So we're going to take, we don't know A, they didn't tell us that, so leave it as A. 1/2 is already a number, so we leave it a number. Let's take base 1 plus base 2, base 1 plus base 2, 9.4 plus 4.6, and then times the height, which is 3.5, right there. Order of operations says I need to do everything in the parentheses first. So 9.4 plus 4.6 is in the parentheses. I will add those together. And when those are added together, we get 14.0 or just 14. Now I'm going to do this 1/2 times 14 because half of 14 is really easy to do in my head. Half of 14 is 7. And then all I need is to do the rest, the 7 times 3.5, because I already calculated that. That gave me that. 7 times 3.5, that's 35, and then 21, 22, 23, 24, one baby in the car, 24.5. The area of that trapezoid is 24.5 centimeters squared. Again, that's just following the steps. Write the formula, fill in known dimensions, solve using order of operations. Let's look at one example that requires us to use our inverse operations to isolate variable. Let's look at how that happens. Okay, here's another example. We have the area of trapezoid is 702 inches square. Find the height of the trapezoid. We'll write the formula, fill in the known dimensions, and solve using order of operations and, if needed, inverse operations to isolate a variable. So this time we weren't told height, so that's problematic, but they did tell us area, so I'm okay, I guess. The steps, the good news is the steps don't change when that happens. You're still going to follow the same steps. start by writing the formula. So there is our formula. And then fill in the known dimensions. Okay, well this time I know the area, so I'm not going to leave A as A because I know that value. So I'm going to instead substitute 702 in its place. Then I have the 1/2 is a number already. I have base 1 as 20 and base 2 as 34. Remember how I said it doesn't matter which you call base 1 or base 2. So base 1 is 20 and base 2 is 34. Oops, we want a better color than that. What I don't know is the height. That's the question mark, so I'm going to leave that as an H. I only have one variable, so I can solve this. Let's clean things up a little bit. Order of operations says, first I need to take care of this addition. 20 plus 34 is going to be 54. And 1/2 times 54, that's 54 cut in half, so I'll do 54 divided by 2. That's going to be 4. Oops, that's not going to be 4. I'm getting ahead of myself. That's going to go in 2 times to give me 4, and 2 goes into 14 7 times. So this will be 27. Okay, this is where now I need to use inverse operations to isolate my variable, because on this side of the scale I have 702, and on this side of the scale I have 27 times h. I need to do the opposite of times 27 to isolate my variable h so I can know who he is and what he is. So h is being multiplied by 27. The inverse of multiply by 27 is to divide by 27. If I do that to one side of the equation, I must do that to the other side of the equation, and that's going to cancel out on that side, leaving me with just h. And I just need to do 702 divided by 27. Well, that's going to go in twice here, and that will leave me with 16 left over. Bring the 2 down. I'm guessing maybe 5? 10, 11, 12, 13. No, more than that, I think. So let's try 6. That is 42, 12, 13, 14, 15, 16. Ding, ding, ding. Winner, winner, chicken dinner. It is 6. My answer is 26. The height of that trapezoid is 26. So as long as they give us enough information and I only have one variable to solve, I can solve for that variable. So sometimes, most of the time we've been getting, I get all of my dimensions, I need to find the area. You will come across some of these that are, they give you the area but they leave off the height, or they give you the area and they leave off one of the bases. So I don't know if they'd leave off one of the bases just because that sum needs to happen first. Anyways, you'll just follow through the steps that you need to in order to solve for whichever unknown you have, and you'll be able to find it. So that's all this lesson is doing. Write the formula, fill in your known dimensions, and solve using the skills you've learned. You've got this. You're going to do just fine.